Today we are going to be simplifying rational functions. So a good first question to ask is, what is a rational function? So we would ask this in class. So a rational function is a quotient of polynomial functions. So if that is true, if a rational function is a quotient of polynomial functions, then it should be able to be written as some function of x divided by another function of x, where p and q here are polynomial functions, and since q is in the denominator, q cannot be the zero function. Okay, so that's what a rational function is. When I see rational, I think fractional. They kind of rhyme. Well, they do rhyme. Rational, fractional. So know that. All right. So when we perform operations, when we simplify or perform operations on rational functions, it's very similar to operations that we perform on numerical fractions. So let's talk about addition and subtraction of rational functions. And to lead into that, we're going to examine what would we do if we were just adding two fractions together. Well, to add fractions, we have to get a common denominator. So if our two denominators are 7 and 4, the common denominator there would be 28. So we would get a fraction with a denominator of 28. This is how I do it. Okay, so the first fraction, it was 2 over 7. Now we want the denominator to be 28. You multiply 7 times 4 to get 28, so you have to multiply 2 times 4 to get this common denominator. For the second one, we're adding, so I'll put a plus here. You multiply 4 times 7 to get 28, so we must multiply 3 times 7 to keep everything equal. So we have 8 plus 21, which is 29, divided by 28. So that is how you add numerical fractions. Very similar process to adding rational functions. We're going to get a common denominator and do the same process. Here, these two denominators have nothing in common. They're completely different. So the common denominator here is going to be the product of x plus 2 and x minus 1. X plus 2 times x minus 1. For the first fraction, the 3 must be multiplied by the x minus 1 to get the common denominator. There's a plus in between them. This 4x has to be multiplied by the x plus 2. Okay, and that is, we did add these two rational functions together. That would be, next year in calculus, that would be a safe spot. Okay, however, we're going to simplify this. I have found out that on FRQs for the AP Precalculus class, you are still required to simplify. So we're going to distribute the top here, so 3x minus 3 plus 4x squared plus 8x. The denominator, however, I am not going to multiply out, because the whole point of the only reason I'm multiplying out here is to see if I can factor this to get it to be one of the factors in the denominator. So I don't want to multiply this out, otherwise I'm just going to have to factor it again. So I'm going to leave that x plus 2 times x minus 1. And up here we're going to have 4x squared plus 11x minus 3. And does the numerator factor? Does the numerator factor? It does factor. It can factor. My question is, can it factor into one of these terms? Absolutely not. There's no way it can factor. Well, it factors into, and we can go ahead and factor this if we want to. It factors into 4x and x. I'll need the 3 here, a 1 here. There's a plus, so I need a plus there, minus there, and that's how it factors. But you see we didn't get a term here that would reduce. Since we didn't get a term that would reduce, we could have left the answer like this. Okay, the only reason you would want to factor is if one of your factors is going to be reduced with one of the factors that is in the denominator. Okay. Alrighty. Okay. What about if we have three terms? I have a rational function plus another rational function minus a third rational function. So we are going to still get a common denominator. What will the denominator be? Well, for this first fraction, this first rational function, it has a denominator that can be factored into x plus 5, x minus 5. So what is the common denominator? The common denominator is x plus 5 times x minus 5. Okay, starting up here with the x. What does the x need to be multiplied by to get this denominator? Nothing. It just can stay x. Plus 1 times, what does the 1 need to be multiplied by? Well, the 1 needs to be multiplied by an x plus 5. If you want to put a 1 there, you can, but that's that. Minus the 2x. What does the 2x need to be multiplied by? The 2x needs to be multiplied by an x minus 5. Okay, just like before, I'm going to simplify this because I need to see, can it be factored into an x plus 5 or an x minus 5. Here I'm going to have x plus 5 minus 2x squared plus 10x divided by the same denominator. And so I'm going to write this as negative 2x squared plus 12x, right, plus 5. And this time that numerator does not even factor, so we would just leave it like that. Okay, the next one. This first rational function, the denominator can be factored into x plus 4, x minus 1. So the common denominator will be, I have x plus 4, x minus 1, and I have an x minus 1 here. So the common denominator will be x plus 4 times x minus 1. This x does not need to be multiplied by anything, minus 2 times the 2 needs to be multiplied by the x plus 4. So this is x minus 2x minus 8 over x plus 4 times x minus 1, which is negative x minus 8 over x plus 4 times x minus 1. We can leave this answer like this. I will tell you that for on an AP problem, a multiple choice problem, they would factor out a negative 1 from the numerator. Factor out a negative 1, and they would put that negative out in front of the entire fraction. So their AP multiple choice correct answer would be this. Okay? So a little note on that. All right, number 5. Okay, we need to factor here. Let's factor the denominators because we're looking for a common denominator. The first denominator factors into x plus 4, x minus 4. And the second denominator factors into x plus 4, x plus 1. So what needs to be the common denominator? Well, the x plus 4 is in common, so we just need one of those. We also need an x minus 4, and we also need an x plus 1. So this 3 needs to be multiplied by the x plus 1 minus 3 times, what does the 3 over here need to be multiplied by? It needs to be multiplied by an x minus 4. So we have 3x plus 3 minus 3x plus 12 divided by that same denominator, which is equal to 15 divided by the same denominator. And that's just an assortment of adding and subtracting rational functions. Let's take a look at multiplication of rational functions. And just like before, we're going to first examine what we would do to multiply two fractions, two numerical fractions together. Well, we have a choice when we multiply fractions together. We can either just dive in and multiply the numerators together and the denominators together and then reduce. There's a 2 in common. Or we can reduce first and then multiply the numerators together and the denominators together. If we reduce first, I see a 2 and a 4. 2 goes into 4 twice, leaving 1 on top and a 2 on the bottom over there. Nothing else can be reduced. 1 times 3 is 3. 7 times 2 is 14. And of course, we got the same answer. I don't care how you do it. If you want to reduce first and then multiply, great. If you want to multiply first, then reduce, great. You will see me every single time, well, almost every single time, reduce first and then multiply, because I prefer to multiply smaller numbers together than larger numbers together. And sometimes, it didn't make much of a difference here, but sometimes it makes a big difference. All right, so our first step in all of these is going to be to factor anything that can be factored. So for this first function, this x plus 3 cannot be factored, right? And we're dividing by this function. You know, I think since we are being multiplied together, I'm going to go right to this other numerator and just keep multiplying out. So this numerator can be factored into x minus 1 squared, right? There's going to be another x minus 1 divided by. This denominator can be factored into x plus 2, x minus 1. This denominator can be factored into x plus 3, x minus 3. Okay, now, clearly we have some things that can be reduced. However, this equal sign is very, very powerful. We never want to say, I can say that this is equal to this, and it absolutely is. It definitely is equal to that. All I did was factor. But once you start canceling out, this equal sign still means equal to. Can I just cancel x minus 1 and x minus 1 and rewrite it without the x minus 1? Are those exactly the same thing? No, they are not. So we're going to need to be careful. Yes, we're going to reduce, but we need to make a qualification when we do reduce. We're reducing out the x minus 1s. We are reducing out the x plus 3s. I am left with x minus 1 in the numerator. I don't need parentheses because it's the only thing up there. And x plus 2 and an x minus 3 in the denominator if x is not equal to 1 or negative 3. That's the qualification. Yes, these are equal if this is true. All right? So whenever you cancel things out, make that qualification. Otherwise, this is not equal. Be careful with that. Okay, that's one of the keys since we're in rational. We didn't have to worry about that with numbers because we could tell that the denominator wasn't 0. But here, this is only true if the denominator wasn't 0 before. So, alrighty. Again, if I graphed this and I graphed that, if I graphed those two, are they identical? No, they're not. This one has 2 holes. This has no holes. So you cannot say that they're equal if they're not equal. So be careful. Alrighty. Hopefully that's all right. Let's do another one before we move on. Okay. This x minus 1 is not seen with a denominator, so we know that that x minus 1 has a denominator of 1, right? If you like, you can just put that over 1 if you want to, okay? Times 10 times x plus 2, x minus 2, divided by 1 times x plus 2 times x plus 2 times 2x and x, 1 and 1, minus and minus. Foil that back out and make sure you didn't make a mistake. We did not. Okay, so what cancels out? The x minus 1s cancel. The x minus, oh, nope, never mind. Never mind, that did not cancel. An x plus 2 cancels, and that's it. So we're left with the 10 times an x minus 2 divided by x plus 2 times 2x minus 1 if x is not equal to negative 2 or 1. Alrighty? Very good. Okay, what about division? In this course and beyond, you likely will not see this division symbol to mean division. Instead, we just use fraction bars almost all the time. So keep that in mind. However, when you have rational functions being divided by each other, it creates a complex fraction, which is a fraction within a fraction. So you won't see it like this. Instead, you'll see it like this. So how do we divide fractions? Well, most time in class, kids will say you multiply by instead of dividing by a fraction, you multiply by its reciprocal. Leave the 2 over 15 alone, multiply by the reciprocal of 6/5, which is 5 over 6. And now it's just a multiplication problem. You can either reduce then multiply or multiply then reduce, either one. I don't want to multiply 15 times 6, so I'm going to reduce. 2 goes into 6 3 times, 1 on the numerator there. 5 goes into 15 3 times, 1 in the numerator. So this is 1 over 9. Alrighty? So in number 10 here, we're dividing rational functions. So we have the x over x minus 2, and we're multiplying by the reciprocal of this, right? So I'm going to, as I write the reciprocal, I'm going to go ahead and factor the x squared minus 4. So x plus 2, x minus 2, divided by the 3x. Okay. So an x minus 2 will reduce out, and an x will reduce out. And we will be left with x plus 2 divided by 3 if x is not 2 or 0. Okay? Another way to write this that you might see as a multiple choice question answer is 1/3 of x plus 2. They mean the same thing. So either way. All right, let me give you an alternative. In a problem like number 11, where we have a complex fraction and it's messy, it is very messy. Every time you'll see me do the same thing here. I like to, instead of adding to or subtracting with fractions, getting a common denominator here, getting a common denominator here, adding, and then multiplying by the reciprocal, instead of doing that, which is, mathematically that is fine to do. Instead, though, I like to immediately get rid of the little denominators, in this case the 5 and the x, by multiplying the top and the bottom by 5x. If I multiply top and bottom by 5x, it will get rid of this 5 and that little x. All right, x over 5 times 5x. The 5's cancel, and we're left with x squared. Minus 3 times 5x, that's going to be a minus 15x. Divided by 4 times 5x is 20x, plus 2 over x. The x's will cancel. I'm left with 2 times 5, which is 10. This is x times x minus 15 divided by 10 times 2x plus 1, nothing reduced, so we could have left it like this. So multiplying by just the 5x saved us a ton of work, all right? It really did. So in number 12, there's a 5 and an x in the little denominators. So once again, I'm going to multiply by 5x over 5x. And we will get 1 over 5 times 5x is x minus 1 over x times 5x is 5 divided by x minus 5 times 5x. Right? The x minus 5s will cancel, leaving a 1 up on top, so it's 1 over 5x if x is not equal to 5. When you cancel things out, remember, saying that these two are equal is powerful, and these are only equal if x is not equal to 5. Okay? All right, one more. What would we multiply by here? Well, what are the little denominators? X plus 2, and 3. So I'm going to multiply by 3 times x plus 2. Here the x plus 2's will cancel. I'm left with 5 times 3, so 15 in the numerator. Okay, here we're distributing, so the 3's will cancel. I'm left with 1 times x plus 2 minus, here the x plus 2's cancel, and I'm left with 6. So this is 15 divided by x minus 4. And that's it. That is it. Alrighty? So that is operations, or simplifying rational expressions.